In our early discussion, we said that if an enable event actually occur, the effects of its actions would be as if making a transition between the two states, right? If you remember the examples we did, we talk about here, you can see from this state over here, we're making a transition to another state by having the occurrence of the event MLN. And here in this longer trace, we actually got from the initial states and the event ML out occur for 3 times consecutively. So that's why we got 1 to 2, 2 to 3, and 3 to 4, 4 states over here. So that's kind of the idea about state transition. That's something I would like you to make sure you understood before you actually move on. What we want to talk about now in this part is to address more specifically about actions for a particular event, especially when the event is enabled and indeed occurred. What does it really mean when the state transition really occur? That's something I would like to talk about. And the way we formalize this without any ambiguity is to talk about the before-after predicates. So that's something I would like to address in the current part for the lecture, for the module. All right, let me now go over some bullet points, and then I will go back to the notes whenever necessary. Okay. So let's now talk about, well, we're talking about an enabled event. Remember, every event may have the guard specified. In the case you don't really see the guard for a particular event, like our MLN and ML out, in which case it will be considered as guard being true over here, meaning that the events are always enabled, meaning that they can just occur at every state. That's something, it's like a special case that you want to watch out for. Okay. Right, so there are 2 notions of the states whenever a state transition occur, or whenever an event actually occur, because it's enabled. Okay, 2 notions. So one is called the before or pre-states. So the textbook actually called this the before states. That's the before in the before-after predicate, right? But it's also very common for people to call pre-states. I prefer calling them pre-state, but I would say for you, doesn't really matter. They're both valid. But if I say pre-state, hopefully you will also realize I'm really talking about the before states over here, right? So what's really a state? We talk about a state should be a configuration that's actually a valid member in the state space of the model that we're talking about, right? I'll try to visualize this a bit in a moment. And so that would be the configuration or the states just before the effects of the actions actually take place for that particular event, right? So before the event occur, so we're talking about the starting states for the event to occur. So that'll be so-called the pre or before states. And symmetrically, what about at the completion of the actions for the events? In that case, it will be called after, right? You can see after as opposed to before, and also post as opposed to pre over here. And of course, the after over here is really what we meant over here, the after, the before-after predicate. So the before-after predicate, which we're going to speak about later in the slides, is really about what's really the formal relationship in terms of the predicates between the pre and post states, or between the before and after states. That's really what the name comes from. And the post state will just be the configuration, again, just another states that will be resulted from after the event's action take effects, right? So these are very important notions that you want to really distinguish between the pre and post states. Later on, when we actually express the proof obligations of the proof obligation that are related to events, in which case we have to use before-after predicate. Whenever you want to prove something about the events, you want to distinguish between the pre and post states. That's really crucial. Okay, just remember. And let me do a little bit of annotation over here. I'll get to the specific example of our initial model in just a moment. Let me just make sure you understand what a pre and post state are visually. Okay, you can think about we are talking about an event that will actually take place, right? Think about an event is more like making a transition, right? So this is an event. Events, for example, E actually occurs. If event E occurs, so that means we're going to execute its action, right? And we talk about 2 states. The starting states right before the event actually occurs. So this will be the so-called pre-states, right? So this will be, let me just color that properly. So this will be the so-called pre-states. Or according to the textbook, it's also called the before states. Both are valid. Okay, and then upon the completion of the actions of the event V, of the event E, right? In that case, it's actually called the so-called post states or after states. Okay, so let me write it down. So it's called the post states or the after states. All right, so that's really how you should really distinguish between the two states. And what's really so important about these two states, right? Let me just annotate further. In the case of the pre-states, so that means the guard of E evaluates true. Otherwise, E simply just is disabled, right? So we're talking about E can only occur if it is enabled. And E will be enabled if its guard actually evaluates the true, right? This is kind of logical. So you want to make sure, so it's guaranteed. If we say that an event actually occur, the pre-states, the starting state for the event to occur, must satisfy its guarding constraint. Otherwise, it will not be enabled in the first place, right? That's obvious. And what about the post-states? And the post-states over here, what's really important about it is, the state changed from the pre-states according to E's action. Okay, we'll see example in just a moment. What I'm trying to say is, we talk about the states, the state being a valid configuration of the state space. So in this case, we have certain values for the constant and also variables. And when E occurs, we're going to modify the variables and constants according to how the actions are specified. In which case, they're going to have their new values in the resulting states. So that's really what I meant. All right. So for the pre-state, you definitely want to pay attention to the guard of the events. And for the post-states, you want to talk about the changes from the pre-states according to the action. All right. And one more thing to note, and then we'll look at example. And the pre-state over here, just notice that it should be a member of the state space. So this should be a member of the, okay, let me put it that way. So that'll be the right direction. The pre-state is actually a member of the state space of the model, right? It's a valid configuration. Similarly, the post-states should also be a member of the state space of the model, both of them. So that's why I was able to actually do some simulation with some concrete configuration over here, right? But however, when you do theorem proving, you have to prove them abstractly at a more abstract level using just predicate inference rules. That's something we'll see later. All right. All right. I believe that's pretty much what I want to say just for now. And so we talk about pre-state, we talk about post-state, and also state transition, right? So this will be the transition from one state to another. Let's now go back. And when an enable event occurs, its action causes a transition from the pre-state to post-state, exactly what I just visualized. And let's now take a look at the example for our two events. You want to distinguish very well between the event actions versus the before-after predicate, right? So these are the two things I would like to further illustrate, okay? And let's start with something we know already, the events over here, right? So these parts are just the actions, right? Let's now annotate it very quickly. So these two parts over here, this and also this, so these are the actions for the events. So these are simply just actions, right? And of course, it could be, each event may have more than one actions, but in this case, we just got a single one, okay? And it's also very important to think about this colon equal to, right? You really don't want to think of it as variable assignment, like a programming concept. That's a no-no, okay? Variable assignments. Right? That's not a way to think of it, even though you thought that might be a good analogy for you to understand. But the reason I really don't want you to think that way is because it's indeed more like a specification rather than implementation. You don't really want to mix the different levels of abstraction. So here we only are talking about specification, okay? So these two, what I want you to think of is this one over here and also this one over here. So they are only just specification. Okay, so here it just spells specification. Rather than implementation. And the way to understand colon equal rather than assignments, what you want to think of it is, you think of it like a check. That's the way to think of it. It's like an N in the post states becomes its pre-state value plus 1. Plus 1. Right, so here I'm actually talking about something we just introduced you to. So we talk about pre-state value, and also we talk about the post states, right? So these are the two things we're talking about. So you can think about the syntax wise whenever we talk about the left hand side of the variable. So this will be the post state value. And the purple syntax over there, right? Let me just be careful. And this guy over here, colon equal, simply means becomes, rather than assign, right? And then this part over here is about some evaluation in the pre-states. So this will be the value we want to assign. Oh, hey, this will be the value that we want the post-state value to become, right? Gotta be very careful. And this part over here, let me just try to put it here, will be the pre-states. Right? Whatever pre-state value you can use to evaluate this expression, once you get it, let the post-state value becomes this particular evaluation. That's really what's happening over here. Even though this is a very simple example about event action, but I think it does exemplify all the various concepts that you should really know in order to continue with the reasoning, which we'll do later. All right, so let's now talk about, so that's about it for actions. So the most important thing is to understand these two are not variable assignments. They are specification for the pre-state and also post-state value, right? That's something you want to keep in mind. Let's now move on to the next part, which is about before-after predicate. As long as you already understood about what this really means, and also this means the post-states and this means the pre-state, you will be able to understand this part very clearly, very easily. Except that we have to explain what does it really mean when we say n prime versus n, right? So either we got a prime version of the variable n, or we got an unprimed version of the variable n. That's something we want to discuss as well. And the before-after predicates are going to be how we will express the proof obligations related to event actions. For example, about invariant preservation. That's something we'll see later. But for now, what I will do is I'm just going to give you a heads up for later. Before-after predicates will be the formats in which we're going to specify the proof obligations for event related related to the events. Okay. So this will be how we specify the proof obligations related to events. Right? That's something we'll see later, but just a heads up. Okay? But now we need to understand exactly what we really meant over here, n prime and also n, right? Let me give the rule over here just for any variable, let's say x. And x can be instantiated into maybe n, for example. Right? Let me put down the rule. So for any variable x, okay, so we actually use the unprimed version, so variable x over here. So unprimed version, in this case that'll be x, denotes its value in the pre-states. All right, so that's that one be easy, simply just x. Whereas the prime version, let me just make it a little bit smaller, right? Otherwise I cannot really fit in the two rules. Okay, and the prime version which will be just prime over here, x prime, denotes its value in the post states. Right, so that's why I try to clarify about the difference between pre-state and post-state in the very beginning of this part. It's so important. Right, let's now try to so here what we are saying is, when you talk about x, it's really about the value for x in the pre-states. And when you talk about x prime, it's really about its value in the post-states. Right, it's an easy principle that we're going to apply. And let's now try to study maybe one of the before-after predicates. And this will be one example over here. Let's take a look. If you look at this, m prime equals n plus 1. This is a predicate. Well, in some way it's a proposition, but remember proposition, every proposition is a predicate. Knowing that it can be a predicate means that later on we might see some universal or existential quantification over maybe that can appear in the before-after predicate, right? Because predicate includes the logical quantification, which we'll see maybe later. Okay, so here what you can see is the n over here is the pre-state value for variable n, and n prime over here is the post-state value for the variable n. So what exactly is this equality over here? Let me make some room on the notes to write this properly. So bear with me just for about one moment. Let me move this part over here to here. Okay, and then let me move this one to over here. That's still visible. Good. And this is the principle, which is also very important. I'm gonna put, sorry, and for this part over here, I'm going to put it over here. All right, good. So what I will do is I'm going to explain this before-after predicate over here. Okay, let me put it here. So this is the before-after predicate that we have to understand properly, because it's going to be used to state the proof obligations for many of them later. Right? So we want to. So this is more like a it's one example for before-after predicate. So I'm going to say before-after predicate for short, BAP over here. It's really trying to characterize the effects of the occurrence of the events ML out in terms of the relationship between the before state value and the post state value. Basically, that's what it is trying to do. Let me write it down. Okay, the effects of ML out occurrence is characterized as a relation between its pre-states and post-states. And let me copy that particular before-after predicate over here. You can see it's m prime is equal to, and by the way, this is not assignments as in Java, it's just mathematical equality, is equal to n plus 1. So now you can see that exactly. It's a relation between its pre-states, which is n, and also the post-states over here, which is the n prime. And we talk about relation, right? So when we talk about as a relation, and what's a relationship? For example, here it would be equality. So if I want to draw a connection or relation between the pre-state value and the post-state value for variable n, I'm saying that if you go from pre-state to post-states, the post-state value for n, which is denoted as n prime, will be exactly equal to its pre-state value plus 1. That's really consistent with how we interpreted the colon equal becomes operator. All right. Now guys, hopefully you don't mind the repetition, but I think it's really important concept. Otherwise, you will definitely struggle with understanding the proof obligation later. So that's why I want to make sure the basic is explained as clearly or as completely as possible. Right? Just one more annotation, and then we can go back to slides. This will be post-state value for n, and this will be over here the pre-state value for n. Right? Just make sure you try to review the actions for the events. Make sure you understand that this is a specification, and also understand that this accordingly formalizes what we are trying to do over here. And also understand the notion between the pre-state and post-states. And what's so special about pre-state and post-state. Everything we have said. Okay, so that's about what I want to say about these concepts. Let me go back. And you can see all the things I have said have been summarized as well as a bullet points here. But I would say make sure you understand everything which I already wrote on the notes. Alright, I think we are now ready to really talk about the proof obligation that would be associated with the events. For example, how we can preserve the invariance that we declare in our model between occurrences of events. That's something we'll see. But I think for this week, it will be okay. It will be enough for you to really study up to now. I think this week we covered quite many concepts about modeling. Model state space, and also we talk about events. We talk about axioms, constant variables, and also coming up with the counter example event trace to show the invariant violation, and also the pre-state, post-states that we just spoke about in this part. So review all these, and then next week we're gonna talk about how we can handle proof obligations. All right, stay tuned, and then I'll see you next week.